How about now? Hi, hello, and welcome to the show. It's me, John Park. Good thing I can see that one VU meter over there that wasn't doing anything. I was like, wait a second. I think I am very, very quiet. Hello, and thanks for joining us here for JP's product pick of the week. As is our custom here on Tuesdays, I like to show you a cool new product or sometimes an oldie but goodie and give you an enormous discount on that product. So that you can go and pick some up and enjoy yourself with them. So this is the URL you want to head to if you want to check out this week's product pick. And I'm going to go ahead and refresh mine to double check that, yes, they have gone back in stock. They are listed at half off, 50% off. You can go there. Just go to that QR code there, that URL. This show is playing from inside of a tiny little window, maybe not so tiny, but a window nonetheless inside the product page. So you can watch the show and read up on the product and see if it's something you want to get. I can stop being so mysterious about it though and let Lady Ada tell you what this week's product pick is. So take it away, Lady Ada.
The HUSB238. Yay! I've been working on this for a couple of years. It suffered from a silicon shortage, and now it's back. This is a really cool chip. So we like USB power delivery here. It's a great alternative to infinite DC power jacks in a bin, in your basement, or under your bed, or having USB-A cables that can only provide you with 5 volts, maybe 2 amps max. So USB power delivery for USB Type-C, and we have a guide all about it. Can give you up to 20 volts and up to 3 or 5 amps, depending on whether the cable can handle it. And that's really great because a lot of times you have, say, like a monitor you were showing me, and it needed, 18 volts, 3 amps, and you're like, where am I going to find an 18-volt adapter? Well, if you have USB power delivery, it's easy. You have only one adapter, and that adapter can provide any voltages you need. So let's go to the overhead real fast, and I'll show power delivery, power supply. So this is a power delivery capable power supply. And you'll see here, I mean, it has a couple outlets. That's why you're like, why is there so many numbers? Because it can do 100, 120, and then this is an 18-watt adapter. So you see here on the USB-C, it's like, I can do up to 100 watts, 5 volts, 3 amps, 9 volts, 3 amps, 12 volts, 3 amps, 15 or 20, up to 5 amps. But you're like, how do I actually get that out? If you use a normal USB-C cable, to your device, unless you know how to request those higher voltages, you'll always just get the 5 volts. So you need a chip that talks to, or firmware that talks to the PD source chip in here. You need the sync chip, talk to the source chip and say, hey, I want you to give me 20 volts. It's not going to give you 20 volts by default. It'll always give you 5 volts default, and you have to request the higher voltages. And that's where the HUSB comes in. So if you look at the top of this board, by default, you'll see there's a jumper that says 5 volts. If you cut that jumper and solder close the 9, 12, 15, or 18, or keep it open and it does 20, it'll automatically request from the power supply that voltage that you wanted. And on top of that, it also has a I2C interface that you can use. And we have a library written in Arduino that you can tell it, the chip, hey, what voltages are available? And then you can pick and choose, dynamically changing the voltage. So, your robot or your motor or whatever starts out, and you're like, well, let's try 9 volts. And then at some point they're like, wait, I need even more power. You can boost it up to 15 or 20. And you can adjust back and forth based on what's available. So let's look at this demo. So I've got here the HUSB, and this is plugged into one of these wall adapters I just showed off with the USB-C ports, and it can provide multiple voltages. And then I have here this is just an ESP feather. I just chose it because it has a nice display. It is communicating over I2C. I've got it wired up to I2C, and it's requesting different voltages. And then if I plug into here, no, if I plug into, sorry, I gotta read this. Okay, this isn't a ground. And I have my multimeter, and my multimeter is working. There you go. You can see that the voltage coming out is in fact going from 9, 12, 15 up to 20, and then it cycles back to 5. So you can dynamically, change whatever voltage you want. You request what's available, and then you can cycle through it. But if you don't want to use a microcontroller, you don't have to. So try unplugging this. if you, hold on, I have to reset this because it was just, it was just programmed over I2C. So by default, I have this jumper. You see, I tried every jumper setting. I have the 12-volt jumper set. And so by default, it will now give me 12 volts output. So you don't need a microcontroller. You do need to power cycle it if you just programmed it over I2C. But by default, it will go with what the jumper says. And then over I2C, you can set it to something else. So it's kind of the best of all worlds for USB PD. It's inexpensive. I've got this nice chunky pass transistor here, and set it with jumpers if you like, and it's fixed. You can solder in a terminal block if you like, or use I2C and you have, a more dynamic, customizable USB PD experience. So, either way. Also, you can use it with a microcontroller and not use the I2C. You can use it to get your voltage, and then, this could do some other work with the over USB, because I have the D- and D+ lines brought out here. So this can be your main connection for USB-C, and then this goes to your microcontroller. I just got to warn people, this V+ pin, don't forget, it can go up to 20 volts. So if you're using this to power your project, you need a regulator that can take up to 20 volts if you request it, and bring it down to 3.3 or 5 volts.
Ah, yes, indeed. Look, that's this week's product pick. It is the HUSB238 USB-C Power Delivery Breakout. This is a really cool board. What this allows you to do is take any of these modern fancy USB-C power delivery bricks, which can give you a whole bunch of different voltages. We're used to USB being 5 volt roughly. Well, not anymore. All bets are off. With USB-C and some of the more recent changes, we can now request different voltages from this at different current levels. So pretty typical. 5, yes. 9, 12, 15, 18, 20. These are all possible on this one right here. And this one is an Anker, ANKER brand brick. I think these were about 55 bucks on Amazon yesterday. It might have gone back up to around 70 or 80. But really nice brick. Same with this one. This is a MacBook brick that I have, and I actually don't use this because the brick that my monitor came with now powers everything. So this is kind of a spare, nice, hefty power supply that can give me a selection of voltages, except, like Lady Ada said, if you just plug a USB-C cable into this, it's going to be 5 volt. That's what it negotiates in absence of some other command. You're going to get 5 volts out of this. Well, if you have devices that want 12, that want 20, what you need is this USB sync chip. This is a chip that can say, hey, power supply, give me a different voltage. There are, as Lady Ada said, a couple of different ways this works. One, you can use I2C. So if some particular needs that may be changing, you can use a microcontroller and tell this what to say to the power brick. The more simple use is to simply jumper some of those little connections that you see. There's an image right there. So in the upper right corner, you'll see there, by default, we have bridged that connection for 5 volt. If you cut that, you're going to get the 20 volt, as it says at the bottom, all open. Everything else is a selectable, so if you blob some solder across the 15 volt there, you will get 15 volts. And what this is doing is actually just setting different resistor values. There's like a 6K resistor and an 18K resistor, and depending on which of those, the chip reads that and says, okay, this is the message I should send over to the brick. You can also see there is a, this is a nice way to use it, this little terminal block there, screw terminal block. I'm using that on mine to connect up to a couple of wires and a little, what are these, 2.2 millimeter typical DC power jack with center positive. And one thing I recommend for this is label these. I've labeled that one, it's upside down. I've labeled that one 20 volt, and that's because I've cut all those traces. This one should be giving me 20 volts. So let me give you a little live example of this. So I'm going to go to this down shooter here. Let me put a little miniature me off in the corner. So this is a little voltmeter, a little panel meter, and I have one of these little splitters so that I can take my voltage from the USB sync chip there. So it's going to plug right into there. And then that voltage will appear on this little panel meter, and it's going to be available here on this end to plug into something. So let me continue the plugging. There's going to be a lot of plugging and unplugging during this show here today. So I'm going to take this brick, I'm going to plug it into a power extension like so. Get that one out of the way. And then I'm going to use a USB-C, USB-C cable. This is one we happen to sell in the store that is up to the task. Not all cables are. And I can plug that into either one of the USB-C outputs there. Now you'll see on my little panel meter here, when I plug in the HUSB238, it is now giving me 20 volts. So it negotiated with I think it said 5 at first, so it looks like there's like a little lag there. But after a moment, it negotiated and bumped it up to the 20 volts, or 19.7 roughly there. So now here's a practical use for this. I have a bigger version of one of these induction coils. This is an induction coil used for our wireless LEDs. So we have these cute little wireless LEDs here. We need a big high voltage induction to generate the power that's needed to light these up wirelessly. And so this one here, this little one, that's 5 volt. That's easy. The one that's mounted inside of here, I can't take it out easily, but it's just a bigger version. That one wants around 20 volts. So I think it can work anywhere from like 12 to 24 or something like that. So I'm going to give it 20, or this 19.6 here, by plugging in the other end of one of those little pigtails there, and you'll see all of my little wireless LEDs lighting up. And you can see here, I can even demonstrate that's wireless, no tricks there. So that is a nice way to say, okay, I've got these really great power supplies. They can supply 2-3 amps of current, I think 5 amps at 20 volts, so great supply, and a really nice way to use it in this case. Now I have a different example. This is some of these little DC motors on these motorized faders. These are running on 9 volts. So what I'm going to do is unplug my USB 328 that is jumpered for 20 volts. I'm going to take that and set that to the side. This one here, again, I've labeled it 9 volts DC. I just have a long cable connected there, long DC cable. And so this one here has the 9 volt jumper set there. So again, I will unplug that from the induction coil. I'm going to plug into my splitter. I'm going to give this power from the same brick, right? Same brick here that was just providing 20, now is going to provide us with 9. So you can see on my little meter here, 9.06 volts. And if I plug the split cable here into my power input for the little flying faders here, you can see they are now moving around under the power of this power brick that's supplying 9 volts. So you could, these are inexpensive, right? Right now these are $2.98. So if you get a few of these, you can integrate them into your projects. You probably don't want them all flying cables like I have here, but we have a really nice 3D printed case you can use, and you can integrate these into your projects so that you can take things that would originally use a DC jack and really just expose to yourself the USB-C connection, maybe label it 20 volt, 10 volt, whatever, but you don't care, right? What you're plugging into it, unlike life where you're grabbing different power bricks, doesn't matter. As long as you have one of these power bricks that can supply the multiple voltages and a USB-C cable that's power delivery compliant, plug it into your project. Your project's going to say, cool, I want 12, I want 15, I want 18, I want 5, whatever it is. You don't need to worry about it. So let me jump over to the product page here so you can take a look at this, and I'll also check and see if there are any questions in the chats. Rufus says, labeling is key, voltage and polarity. Yes, that's a good point. I am guilty in this case of relying on the fact that I've plugged into the plus on plus and a minus on minus, and I know these are center positive. I don't think that's labeled on there, so you really should say with these center positive or center negative. So there's the product pick, right? This is product ID 5807, and it is $2.98 right now, just during the show, right? So if you want to get one of these or a few of these and get up to 10 at this discounted price, throw them in your cart. We have 58 in stock as of the last time I refreshed. Oh my gosh, we're out of stock. I don't need to sell them anymore. You guys bought them. They're all gone. Oh my gosh. I'm sorry if I was yammering and you didn't get any. I'm sure these will be back. They won't be at this ridiculously great price. So if you got them, excellent. Congrats on doing that. And if you didn't, I'm very sorry. But not too bad of a price for what it is, even at the full price. So if you follow the links down below, you can get to the Learn Guide and the 3D printed case. So here is the Learn Guide by Liz Clark. Excellent guide. It takes you through all the pinouts, tells you how to connect it up to your power. Here's a note. This was something I found out yesterday. With the particularities of my power supply, my cable, if I cut both current traces so that it would be trying to get 3 amps, it was actually asking for a little more. I think it was asking for 3.25, and my power supply said, I'm not going to give you that at 9 volts that I was trying to get. So it has sort of a safety mode. It just gave me 5 volt. So it was probably 3 amps at 5 volts, but it didn't think that the supply could give me what I wanted. So I, in the one case, just jumpered the 2 amp one, and that's fine. I'm actually not drawing that much current here. But just so you know, if you see a problem trying to grab the 3 amps and you're seeing the wrong voltage show up, probably you're asking for more than it can give you. You can, as we said before, go in and plug into a microcontroller and configure this with I2C. Liz has a nice example both in CircuitPython and Arduino here, so this will show you how to wire that up. And there is a library and a nice little code example. And if you run this, you will just simply see it spitting out to your meter, 5 volt, 9 volt, 12 volt, 15 volt, 18 volt, 20 volt, and it'll cycle through those. Here is this really cool case that the Ruiz brothers made. So you can 3D print this case, and it gives you access to the screw terminals there, so you can feed in wire, screw it while it's all still in its case, and it's secured in there really nicely. No parts to short out on things. That's a nice way to go. There's also links in here to a typical USB power delivery supply that you can use. We don't sell these in the Adafruit store. This one might be the one I have. Yeah, this is the one I have. So it's back up. Yesterday was the day to get them. They were like 54 bucks. I should have grabbed a second one. Oh, but they have a coupon. They have a 25% off coupon there. So there you go. I'm not trying to give Amazon our business, but that's a nice one. You may already have a power delivery supply, particularly if you have a modern laptop. You've probably got 1 or 2 of those floating around. And this is someone had asked in the chat, I think Rufus, this is the little adapter that I'm using in this case, but you can use, just cut out an old cable. I think Liz shows how to do that in the use case example here. Under use, she attacked an old wall wart and grabbed just a bit of the cable, including a nice little inductor there. That's not the word for it. The thingy. What's the thingy called? Someone in the chat tell me. I can't remember. Oh wow, Jim Hendrickson got that supply for $39 a month or 2 back. Yeah, that thing yo-yos, but it is a pretty good one. So yes, but so here's an example of just taking an old cable. You got plenty of length there. Cut it wherever you want. Use your multimeter to check for center positive, center negative, which one is which, what does your device need, which wire is which. Ferrite bead, thank you, Paul Ramasco. That's a ferrite bead, right? That bolus sitting there, I think that's a ferrite bead. Keeps things from being noisy, right? And that'll do it right there. So let me know, anyone have any other questions? Here was another possibility there. This one with alligator clips. You could attach those to some wire, put those into the terminal block. You could cut this if you want and solder it too. It's not super expensive. You probably want to do that in large volumes, but there you go. That's another choice. We have a few other DIY options for the barrel plugs. All right. Oh, Kevin Orbison says 12 volts optional. The Apple MacBook adapters don't support it. Oh, that's a good point. If it were at all possible for me to read the gray on white text that Apple thinks is so clever, there's no way. I have to put that under a microscope or take a photo of it, but these will tell you what voltages they support and usually the current that you can get at the different voltages so that the math works out. But I didn't know that one didn't do 12. Thank you for the info. All right. That's going to do it. So let me grab this one right here and finish this up. So that is my product pick of the week this week. It is the HUSB238 Power Delivery Breakout. For Adafruit Industries, I'm John Park. This has been JP's product pick of the week. I will see you next time. Bye-bye.